Welcome to a lesson with Dr. Powell. Let's talk about how we can tell that two spans are the exact same. Well, for one, notice that 1, 2, 1 is actually the sum of these two guys right here. If we take this vector and that vector. So 1, 2, 1 is actually in the span of just those vectors there. And so this should be pretty clear that the two spans are the same in that case. But let's be precise in how we would write out a proof for that fact. If we want to show that two sets are the same, let's suppose this is like set A and this is set B. What we need to show is we need to show that A is contained in B, and we need to show that B is contained in A. Okay, so let's be precise about this. Let's suppose that we take an arbitrary element in A. What does it look like? It looks like something like this. A1, 1, 0 plus B, 0, 1, 1 plus C, 1, 2, 1. All right, all we have to do is show that something of this form happens to be of the form of things in B. So maybe something like, and I'll use different letters, maybe like R and K needs to be like R1, 1, 0 plus K, 0, 1, 1. Needs to be of this form. All right. So, well, we know that this is the sum of those two guys. So we could rewrite this as 1, 1, 0 plus 0, 1, 1. And then we can distribute the C to both of these, C and C. And then we're adding this right here. Then notice that we can factor out the same vector across the scalar addition. So we have A plus C multiplied to 1, 1, 0. And then plus, and then we can do the same thing with 0 and 1. So B plus C times 0, 1, 1. Okay, so having this, notice, well, wait a minute, this is of that form, right? Because this is a real number, that's a real number, and that's all we really need. So what we have just done by doing this is we have shown that A is a subset of B. We took an arbitrary element of A and showed that it actually matched the condition for being an arbitrary element of, or to be, that is, an element of B. So now let's go the other way. Take an arbitrary element of B like this, and let's show that it's of the form so this form right here, that is for an element of A. Well, quite clearly it is if we just do this, plus 0 times 1, 2, 1. Aha, it is of the form that describes elements of A. Therefore, we're done with this one. That was the proof. The proof was just simply to realize that you needed to put a plus 0 times something. Now, of course, this really isn't a proof if all I wrote down on my paper was this. What I need to do is use some words, namely the words that I was using here in the video speaking out loud. I was just kind of describing how the proof would go. However, some words would be required. Thanks for watching.